Now like to introduce your moderator for this panel discussion, Bill Hayes. Bill is a veteran broadcast engineer with decades of experience in public media and broadcast operations. Welcome, Bill.
Oh, thank you. Thank you very much. Welcome, everybody. As Cindy pointed out, I'm been around the business for a while. I'm also the Central U.S. Regional Governor for the Society of Motion Picture and Television Engineers. It's a great pleasure to be here. I think this is going to be a very interesting panel. And I'd like to go ahead and start introducing our panel. First, I'd like to introduce Pierre Chevalier, who is the Technical Director at Softron Media Service, where he oversees the development of professional ingest, playback, and live production software. He has deep expertise in ST2110 and IP-based workflows. He brings hands-on insights into building scalable, real-world IP production environments. So, Pierre, welcome. Our second panelist is Srikanth I practice this. Srikanth Renjarajan, sorry, Embedded Business Units Director at Altera. They're shaping strategy for mission critical applications. He brings a semiconductor and embedded systems perspective to the conversation, highlighting the innovations enabling next generation IP and real time media infrastructures. And our final panelist is Andrew Starks, who is the Director of Product Management at Macnica Americas, where he leads product strategy for solutions portfolios. He is also actively contributing to industry initiatives advancing open standards in broadcast and pro AV technologies, including the AIMS project. So, gentlemen, welcome. Before we get started, I'd like to do a quick pulse of the audience. We're going to launch a short poll question, just one question. Let us know where your organization currently is in its 2110 journey. Are you evaluating, piloting, partially deployed, or fully scaled? Okay. So with about almost 70% of the votes counted, we have election year coming up next year, or this year actually. Anyway, it appears that still half of our audience is still evaluating learning. So that'll help sort of steer our conversation. And let's see what we can discover here. I'd like to open this up with asking our panelists to each briefly introduce how ST2110 fits into the organizations that they work with. And I'll start with Pierre.
Oh, yeah. So hello everyone. Yeah, so we are developing software at Softron. So it's an open system, and we try to integrate with different type of customers. We go from small customers just using software on a Mac. So on a MacBook Pro, they just have the MacBook Pro to do the production, but we go up to very high-end productions with a lot of different video inputs and a lot of requirements, and that's where we really see a lot of traction into ST2110 because of all the flexibility, all that it brings to the work. So we've seen that traction, and we started developing, being able to support ST2110, and that's why it's really important for us to get in this train. It's not the easiest one, but I think it's really interesting, and it's I think where the industry goes, not for every part of the workflow, but I think it's important that we get in that.
Thanks, Pierre. Shri, where is Altera in this?
Thank you. So we are a semiconductor company, as you know, and FPGAs are kind of like the backbone for some of this industry, some of the things that we do in this industry. The broadcast industry is, of course, headed the IP way, right? They've been there on that pathway for a while, and they rely on us to get their content across, from the acquisition portion of the flow to the ingest.
Okay, and Andy?
To the consumer. FPGAs lay the framing and the plumbing for the industry, on which I guess folks like Pierre built their superstructure on. That translates to hardware primitives like robust IOs and transceivers for the various protocols, including the one we're going to talk about today for the next hour, but also an efficient protocol implementation on top of that, that is specific to that particular hardware, in this case, SMPTE 2110, backed by PTP protocols and whatever else is required to make this usable. That would mean our tools for programming the FPGA, the Quartus tools, the soft IPs that our partners provide to do the ST2110 protocol layer, the support, the bundled offerings, the entire out-of-box experience, if you will. And all that is needed because that fine-grained level of control that an FPGA platform offers is vital in this industry to tune to the customer workloads and the specific demands they have. It's really a nod to the real-time nature and the determinism that programmable hardware, aka FPGAs, they bring to the table. So that's where we play.
Sri, thank you. I apologize. I had my system froze for a moment. I interrupted you. I apologize. And Andy, your company, Macnica.
Yeah, well, at Macnica, we're all about open standards, and we've been involved in SMPTE 2110 and even all the way back through to 2022 before SMPTE 2110 in developing standards. But for our company, we're really about enabling manufacturers and OEMs to build products with SMPTE 2110, whether that's on embedded devices or in software on PC platforms. We try to hit every platform and hit every place where manufacturers are making products with 2110. So yeah.
All right. Well, so we have a pretty broad range of experience and expertise here. So one of the questions that comes to my mind, I spent a lot of years building facilities. So, but my experiences were in the olden days of NTSC and dedicated wire, and then SDI. A little bit of digital, but not as much as is happening now. So how are IP-based workflows driving different system design decisions compared with, say, SDI? And Andy, I'll let you take first crack at this.
All right. Well, I mean, I think that for one, sort of the fundamental difference is that with SDI, of course, you have one video signal over one cable, right? So every time you want to bring content into a router, that's one cable per feed, right? So I think one of the biggest differences between a SMPTE 2110 system and a SDI system is kind of size. Like when you bring the system into compute and you're using 2110, you'll find that the overall size of the system, the amount of cabling involved, all of that kind of reduces. But the other thing I'll say just briefly is that from a systems level, a packet switch network is very different than a baseband routed network. And with multicasting and the ability to like I say, combine flows on different links, the amount of flexibility that you have is quite a lot. And what I think a lot of people find is that when they first think about going to 2110, they think about it in terms of their SDI system, but it takes a while actually to start to appreciate the additional capabilities and flexibility that you get in a 2110 system. It really requires rethinking things. So.
Yeah, I agree. It's
oh, Pierre, go ahead. I'm sorry.
Yeah, no, that's no, I really
it is a
agree.
discussion.
It's really, yeah, it's that really the fact that the signals are no longer tied to a physical cable. It really brings a lot of flexibility, and we see it in our example. For example, with our software on a Mac Pro, we can record up to 24 channels of 4K 60. But that means that you need to have 24 SDI cables in. And, if you have a look at the back of the computer, you have all these cables that get in, and you have to bring those cables somewhere else. And it brings a lot of challenges. Whereas with ST2110, with just one cable, we can have 8 4K 60 and 32 HD. So it's really opening up what you can do just the physical part, not having to cable that many cables, but also all the flexibility that you can route, because now that you're network based, you don't have to worry so much about, oh, I will put that cable to that video router and that go there. It's really bringing all the flexibility. So it's both the physical part and the flexibility of routing the signals.
Yes, you are kind of cut off Pierre from the physical cable, and that magic happens, I guess, in our domain to some extent. So the need for that reconfigurability, right, using a common design baseline, that's probably the biggest thing that is affecting system design in our world when you go from SDI to 2110. And that reconfigurability, again, has to span all those stages of the video workflow that I talked about, while still dealing with vendor disparities, like each one has their own way of choosing the optional portions of the standard, for example, as well as the basic technological difference between going from SDI to 2110. Like, for example, SDI cables have distance limitations based on resolutions and frame rate of the weak feed. And also, while the number of the cable wires have gone down, the fact is now we have actually more streams, because, as you know, SDI combines video, metadata, and audio, whereas 2110 separates them out. Fewer cables, more streams. So you can see where the problem comes from. That leads to a whole new paradigm of system design at our level, where you have to deal with higher transceiver speeds, 10 gig all the way up to 200 gig and higher, compared to SDI, which tops out at 12 gig. Right? The typical FPGA transceivers are much faster. We use IP switches now, as opposed to SDI point-to-point connection, and these are bidirectional, right? Managing both input and output ports. All of these lead to a different way of thinking. The good news, of course, is that other people have already thought this through before we did. That's the reason why we are moving to IP in the first place. The world of IT has taught us how to use TCP/IP as a IP-based routing and stuff like that. So there is all that thinking is what is driving the system design here. But it's not plug and play. It's not push button yet anyway. So that then leads to the other point of there are still, I will guarantee you, components in a typical broadcast studio which are still SDI, even if they have a headline, a banner which says we are ST2110 compliant studio kind of thing. And the way you get around that is to carefully choose where you take in your SDI, how do you encapsulate it and feed it into an ST2110 flow, and then de-encapsulate it on the other side where you need to get your rendering interfaces. These are all the kind of decisions that plague us on a daily basis that also make our life interesting, but also make it worthwhile to make this a viable transition in real life as opposed to just on paper. Because the benefits on paper are supremely clear. It's these practical difficulties, and I'm sure we'll talk more about this in the next rest of the seminar, this webinar, that make it that translate it to reality effectively, if you will.
Well, yeah, I love your choice of the word plague us. That's the phrase plague us, because it does seem at times it's plaguing us. But that brings up my next question. So as we deploy these systems, we're seeing more general purpose servers, smart NICs, and orchestration becoming central STI 2110 systems. Why is that? I mean, is it what you've just said, or is it more?
I'll continue. So I'll say it this way. Take a modern ST2110 facility, right? There are usually, like, as I said, there are three things. There is the server that runs the media applications, the smart NICs that ensures real-time high bandwidth transport with precision timing typically inside it. And then there's the orchestration piece, which coordinates the entire system, ensuring flows are routed correctly, resources are used efficiently, and all that stuff. And if you ask the high-level one-line pitch, this trio basically enables your software-defined scalable cloud-like media production, where cloud-based networking kind of stuff effectively came into the broadcast industry. And that's where our industry is headed. So servers give you the flexibility, and smart NICs give you the efficient IOs, FPGAs give you the real-time line rate, ultra-low latency processing, that even though it's software-defined broadcasting, that's a term I like to use, SDB, software alone cannot match that. And the hardware acceleration for packet processing, timing, IO, power latency, determinism, all those advantages, that's where they come in. But it's even more fine-grained than that. Like I spoke about the smart NICs, right? The FPGAs, many of those smart NICs used in these environments, they actually have an FPGA inside them. or FPGA-like programmable pipelines for everything from packet pacing. That's one of the things that the 211021 standard does. RTP encapsulation, PTP timestamping, you name it. Even traffic shaping is done with that. Sometimes people talk of dedicated media processing accelerators, MEP 100, right? So again, there, FPGA inside, used for, again, encapsulation. Sometimes we use them for JPEG access encode. Yeah, I spoke earlier about still having to glue in SDI and move it into the IP world. That's SDI to IP gateways. And then hybrid architectures where think of, I don't know, cameras with SDI gear going into an FPGA gateway, going into an IP fabric, going to a server and SmartNIC setup, going into orchestration. There's like FPGAs kind of play all over the place. But to answer your original question, this overall real-time line rate, ultra low latency, those are the key takeaways for our business. And if you want to do that using what the industry has learned over the last 20 years, and here I mean the compute industry, to do IP-based distribution of content, and do the same for our broadcast industry with these specific requirements. Well, that's where general purpose servers, SmartNICs, and orchestration are the foundations on which we build it.
Yeah, that's the. I'll go on into the SmartNIC question. Is for us, I'm talking as software manufacturer. We when we started looking into 2110, we thought about doing it ourselves. We could have gone, it's we can talk software network to the network. So we thought about, well, we could, use there are network ports on the Mac, and we'll do it ourselves. We'll talk to the network ports and manage things ourselves. But we have quickly seen that this is not really a good way of seeing things. We have to, try also in software to keep the cost down. Should we have wanted to do that, it would have been first a lot of work in software development to make sure to do it correctly. But also the fact that with a SmartNIC, you can offload, all the packetization, the PTP alignments, and so on. It's really, for us, we have seen, we quickly stopped. We looked into it. It's not something we went really further in that. But for us using SmartNIC and, the Magnica card, it really allows us, to take more our efforts into the software itself instead of, developing all the things you need to do to have something that works reliably for ST2110. It's not that easy to do. So it's really something that we were happy to deal with Magnica, both for the fact that we are offloading and using an SDK that we are used to work with in order to just ask the card, well, here are the video frames, here are the audio samples, and please output that to 2110. So that really opens up for us.
Yeah, I mean, I think a lot of good things being said. I think one thing I'll just add is that, with things being in IP and things, I think the industry sometimes has a fear of moving towards more IT kind of infrastructure. I think that fear has kind of subsided now as we sort of understand the benefits of leveraging, the scale of general IT. And, that means things like CI/CD or continuous integration, continuous development, containerization, those kinds of techniques to scale systems. And we think of those things, or at least I think of those things a lot of times as data center, tools. But the truth is that I think I read somewhere it was more than 50% or some huge percentage of software systems that people have deployed in their facilities are kind of homegrown systems. And that might mean literally homegrown, or it might mean taking somebody's software and using their API to connect it with something else. But they're doing a lot of these creative things that we used to get done with little adapters, and I call them donkey knuckles, but these little adapters that you have that throw down boxes and things like that. But now that you are working in an IT world, and we can take advantage of those virtualization and containerization technologies, that's a great tool in your back pocket. And what a SmartNIC card does is it really abstracts away the difficult, kind of plumbing part that really doesn't add value to what the customer is doing or what the end user is doing, and it kind of puts that in the background. And I like what Pierre was saying too, is about system resources. The truth is, it's actually kind of, I just had this thought like just recently that like we are actually in a high performance computing environment. Like I always think of high performance computing more about things like financial tech, or trying to figure out genomes or whatever. But our systems are extremely low latency. We're one of the few industries that is pushing network bandwidth almost right to line rate. And so that combination of performance requirements really does require acceleration. And I think that SmartNIC cards really just kind of help customers and developers focus on actual value and not the plumbing part. So,
well, absolutely. It sounds to me like when I first started doing computer-based equipment, it was you basically looked for the most horsepower you could get in the actual computer itself. Now what you're describing sounds like you have to really think more holistically about your infrastructure and look at not just the processing power of your server, but also the capabilities of your interface devices and your entire network as a whole, as opposed to individual islands. So it's very interesting to me to see this change in thinking as we go from the one-to-one connectivity that we did to this basically cloud that we create within our environments, within our operations. So with that in mind, I mean, how are teams managing the explosion of workflows, formats, platforms, operating systems? I grew up sending. My biggest concern was making sure that my signal got from my master control to my transmitter site. Now I have to think about the streaming services and the CDNs and the on-demand services, the fast channels. So how are we dealing with this?
Pierre, how are we dealing with this?
All right, yeah,
I probably should have said Pierre there. I did not. I apologize.
Okay. That's okay. No, well, we on our side, we are macOS only. We often have the question about whether we would do Windows or Linux software, but we won't. we have good reasons for that. We are focused on macOS, so we can really optimize for one platform. We know how it's working, and the fact that it's a closed platform, the macOS, on our side, it's really we have a limited number of computers that we can test with, and any user can go to an Apple store and get a Mac and get our software running. But what we see in our customers is that there is more an explosion, not so much in operating systems, a little bit, of course, but it's more about resolution, frame rate, formats, and codecs, and transmission of the signal. We talk about SDI, there is 2110, there is NDI, and yeah, people ask what they should be using, and I understand that it can be complex to choose. But I think that, because of the industry moving to formats with 4K and even 8K in some cases, you're really moving a lot of data. So you cannot use the same workflows that you used to use for SD. Things have changed. And yeah, people have to decide, depending on what they need to do, what the channel count is important. If they just need to just do one signal from one place to another, if it's nearby, it's SDI. But if you start looking at more channels, then you have to think about how will I make my signal go from place A to place B, and how to make it. So it's really thinking about that. For teams, they have to sit down and think, well, what do I really need? And the good thing of having such a large choice is that you can really pick what fits best your needs.
Okay, I mean, if I can jump on that, I think that's a great point, and I think Pierre's perspective with the Mac is an important one, because the Mac has always had a place in entertainment and broadcast, in terms of creative applications and workflows. So it's always been a central part of it, but it's not always been a well-represented platform in terms of the equipment. And that was something that was really important to Macnica, because our customers are going really to every platform. So like whether you're talking about Linux, Windows, or Mac, or software or hardware or embedded devices, they're everywhere, right? I mean, and you can't, even customers that are, very firmly on one platform or another, will recognize that it is not always their choice. And sometimes they even need to be streaming to a laptop that's not going to have any acceleration at all. So we look at it from that platform perspective, as well as Pierre mentioned, also the explosion in different formats, resolutions, frame rates, and things like that. Now that direct view LEDs are kind of standardizing on SMPTE 2110 as well, and in that world, you've got 444 color spaces and very high frame rates and things like that to deal with too. So the creativity that SMPTE 2110 brings along, it really puts a lot of pressure on solutions providers like Matnica to keep up with all of the ways that it's getting used, for sure.
Yeah, no, all valid points, and I'll say this on top of that. Yes, there is no dispute that this is an explosion, right? That's the right way to frame it. And across container and codec formats, across every stage of the broadcast workflow, these things change. Like obviously, if you think in terms of formats, there's resolution, there's bit depth, codecs. When we talk about them, there's a concept of editing-friendly codecs versus distribution stage codecs. The latter pricing compression, the former pricing time latency, right? And there are too many of them: Apple Res, Move, MXF, and different stages of the video broadcast flow price one versus the other across different vendors. So what is that they all have in common, right? Yes, they require some level of OS support. I know you're fixed on Mac. There are others who go the other way. They maybe supports more than that. The point is, at the end of the day, we want to be able to abstract as much of this complexity away from the end user. And that's really what they seek, right? And our strategy, at least at Altera, is to be able to support the primitives underneath, the relevant formats, accelerate them, and deliver the level of performance that the user demands, effectively future-proofing them from any format change, either in their own different stage of the pipeline or in a future revision of the same broadcast flow when they change it, for whatever reason, because the studio wants to get upgraded, for example. The other thing that is happening, other way the teams manage it, well, they move to standardized platforms, cards, right? That's another way to think of it. And there you want to be able to support something that is not custom bespoke, because as soon as the flow changes, now you have to go get another piece of hardware. Nobody likes that. SDN-like capability, that's basically what the system integrators want. So that they can offer variants to customers with the different personas, and acquisition versus distribution versus post-production kind of guy. And doing all this transparently and as part of a pre-packaged delivery item, that's really the key to success. And the other piece of the puzzle here is the reconfigurability. I mean, given having brought something in here, the user doesn't care, but a system integrator certainly will, like think NEP or somebody. They want the physical consistency of using the same accelerator card, offering the same level of performance guarantees, but moving to a different platform with a different broadcast flow for a different user overnight. I mean, that really is a dream of software-defined broadcasting, right? And that's basically how we think of the problem and how we are approaching offering a solution here.
Well, that's very interesting, because as an end user, I grew up in the industry as an end user, and one of the issues one of the challenges I always faced was as things change, and we talked about this explosion, their need to adapt, the need to deal with different hardware, different software. How as an end using engineer or an organization that's dealing with this, how are they doing tackling these issues, these challenges, in ways that are cost effective, fast, and maintainable? I think in the live environment is really where I've seen the most. In the old days, we used to buy something from Black Box. If you needed it to go from here to here, there was a company called Black Box that made a box. You plug one end in, and out on the other end came what you needed. How are we dealing with that now?
Yeah,
sorry.
It's an interesting challenge here. So let me take a different tack on it. What's the technology stack that we are looking at here that's primed to solve that challenge, right? There is the application layer. That's what, again, the user cares about. Underneath that, there is a platform layer that's access and provisioning in the software-defined broadcasting world of ours.
Mm-hmm.
And then beneath that is where the value comes in and moving to things like SMPTE 2110, which is the network management infrastructure layer, if you want to call it that, with the standard IT approach to managing a network and orchestrating and all that. And if you work your way up the stack, all the media-centric applications sit on top. That's where video and audio mixers live. Great. I don't think that's where the problem is. The challenges that you just referred, they're typically at the lower two levels. How do you do a platform layer that can access and provision and bring up a flow? And then how do you manage the network when things get congested? And how do you move things and route things differently because now the mixture is telling you to do something else? That's basically the problem, right? So there are a few challenges. Interoperability, I mentioned this earlier, it's not still quite plug and play with SMPTE 2110. Vendors pick and choose what they want to build, so that's a problem. Timing is a big issue, right? I mean, this is where we come in. We are more exposed to this. But any time you hear the word jitter, sync stability, your PTP is busted, your clock is drifting, all that is us, right? They don't drop it on us. So that's a problem. The standard networking challenge, multicast, what's your QoS looking like? What's your bandwidth? What kind of architecture? Yes, we use this, what is the term we use? Leaf and spine architecture for routing in a broadcast industry. But at the end of the day, that has to map onto all these QoSs and end-to-end, bandwidth provisioning and latency and round trip and stuff like that. So that's a problem. I'd also say there's a skill gap. I mean, it's mostly kind of getting resolved now, but the broadcast industry is not the IT industry, and you can hire people from the IT industry who don't understand broadcast flows and vice versa. So somebody with TCP/IP knowledge, but also who understands how the broadcast industry does video mixing and rendering is a rarity still. Skill gap, right? Yep. So, and then of course there is the whole control piece and MOS and stuff like that. And then I spoke about the migration aspect. No, nothing is 100% SMPTE today, and equally there's nothing that is 0% SMPTE. So how do you take a studio like that and try to make the glue work? That's the challenge part of it. Solution-wise, start with the timing-wise, what do engineers do? Well, they have to use redundant PTP grandmasters, multiple transparent clocks, kind of makes life easier. You make the networks non-blocking. Technically, that makes your multicast is optimized. Failure, huge problem, right? IPs are all about redundancy. That's where the point to point, if one thing fails, you plug a backup cable. That's what we use in the SDI world. There's no cable to plug because you have presumably multiple paths. So you have to build hitless switching. That kind of, so that you don't drop a single packet and you switch to an alternate pathway. That's the redundancy part of it. There is also monitoring. That's probably the biggest piece. I mean, there are a lot of smart people, but they need data before they can fix something that's going wrong. And diagnosing an IP network is not the same as diagnosing an SDI network. One little analyzer in the path of the SDI cable can do that job. I don't know where the bottleneck is. I don't know who's dropping packets. I don't know where the flow is busted. Stuff like that. So having a lot of telemetry, dashboards, and profilers, which means, of course, guys like me have to build in the hooks to profile and tell you at a packet level what's going on. That's important, and people do that. And lastly, as I said, migration. There's gateways, hybrid routing, phased rollout. First, the acquisition goes SMPTE, then the processing goes, then the distribution goes. That's one way to get around the challenge of not being overwhelmed by the IP world all of a sudden when you come with 20 years of SDI background. There's no one perfect answer, and you have to train those people, of course. As I said, you need somebody with 1 foot in broadcast and 1 foot in IT world. Very rare people. If you can find people like that, good for you. So, bag of tricks. Sorry, that's the best answer I can give you.
Yeah. Yes, I especially like for me as a person who worked in the SDI and the analog world, you could do a lot of your diagnosing, but just looking at the end product, you could tell what was going on with IP and digital. Every project manifests itself the same way. So, Pierre, you must have some comments on this.
Yeah, I wanted to comment on the cost-effective side of things because I know that ST 2110 can represent a significant investment, especially if you design a fully redundant, high bandwidth infrastructure. So what engineers do is that they are more strategic about where the IP adds value. And we see a lot of places where also, the migration is step by step. So it's not like all the infrastructure go all of a sudden to ST2110. We see a lot of hybrid approaches where you still have SDI and then IP workflows that are in the same system. Also, engineers try also to look into the compressed workflows because, in ST2110, you can have uncompressed go through the channel, but if you start looking at 4K, it's a lot of, you have to have, switches with a large bandwidth, but you can compress. There's JPEG XS, of course, that is well known, but we've shown also at IBC that we are introducing ProRes over 2110. So that's a way also to keep costs down, is to make the bandwidth lower, so you lower your cost of all the infrastructure to be able to transit more signals on the same pipeline. So yeah, that's the things, is to really choose where IP is important for you, to lower the bandwidth if you can, and also to keep in mind that because it's IT, you can share the infrastructure for different workflows. The same signals can be used in one case for such production and so on. So you can share also the resources. That's really where people can try to keep costs at a reasonable level.
Yeah, I mean, if I can maybe throw in just a little bit, I think that one thing that, just answering your question from like an infrastructure level, I think one thing that is something to keep in mind for people planning SMPTE 2110 systems is that your network planning, like, provisioning IP addresses, making sure that you've got, enough bandwidth between switches, planning out how you plan to run PTP. So for example, there's more than one thing on your network probably that needs PTP. You probably also have maybe some Dante audio running there, things like that. So, and then also, as Pierre was mentioning, you've got different uses for your network. So you've got to worry about quality control on the network or quality of service. And also VLANs, these kinds of networking challenges that really are not in the SDI world are something that you need to be thinking about. And I think that having someone on your staff that really understands those features of SMPTE 2110 or the features of the infrastructure is probably a pretty critical thing. And it can be easy to underestimate the amount of planning that really ought to go into the network, because as Srikant, sorry, I mispronounced your name, as you were saying, this the it's not as visible, right? So today, and you mentioned the control plane as well. I mean, today the challenge that we have is it's difficult to get a digital twin of the system. So we have to resort to a lot of spreadsheets and a lot of other kind of ad hoc documentation to tell us what our system is actually, how it's actually set up. And if you kind of think about like the switches and things in the network, there's just a lot of little devices that need configuring and tracking and updating and all the things. So to people listening, I would just kind of take note of that and to understand that that networking IT side of it is both a administrative problem, and sometimes it also can be a political challenge, because if you're in a facility that has its own IT policies and things like that, they might have opinions about what switches you can put in there, and you might have needs that they don't really understand fully. When they think multicast, they're thinking voice over IP, like telephone systems, not like line rate constant video going down there. But also too, the upside of it is that, again, this is compute, and the more you can think about your technology in your facility as being on generic compute, meaning that you have a computer, you can load software onto it, the more creativity, the more options kind of open up to you. Tools like Softron are an excellent example of this, that we're seeing less and less like monolithic applications that are, kind of one size fits all for everything. You know, we no longer really have a dedicated video server sitting over here. We have lots of different video servers, and you know, and really thinking about, you know, how can I bend these tools and use their APIs and customize these things to really fit what I need in my station, can oftentimes mean avoiding buying a box that's maybe $40,000, and instead you can use, you know, a SmartNIC and some software and a little bit of scripting, and you can get some pretty creative problems solved like that. So,
well, so given that our poll said that about half of the people are just in the process of planning, which Andy, you've just pointed out, and you've all pointed out, is extraordinarily important to your journey. There's also got to be there's a lot of real world deployments out there. So as these numbers have increased, what's easier with 2110 today, and what's still a challenge? And I'll throw that open to whoever wants to start first.
Well,
I'll say that, you know, what's hard today, or what's easier today now, is the flexibility in terms of getting signals where you want to when the system is set up. And I don't want to make it sound like SMPTE 2110 is some kind of, you know, drag on people or anything like that. It's really not. The once it's set up and once you have it deployed, the amount of flexibility is just really tremendous. And another area that's often overlooked is like OB trucks. You know, if you're in an outside broadcast truck, weight is a big deal, size is a big deal. You know, your rack space and the weight of your truck is quite a big deal. And so now, you know, it's maybe possible to carry a couple extra cameras, or to pack even more equipment into the van, or to save money. So there's a lot of advantages there. But I think that it was brought up earlier. I think that the challenges today still remain kind of in the systemization side of things, meaning like, how do I see my system? How do I visualize it? There is software out there to help with that. There's actually quite a few vendors that make some pretty powerful tools in that regard. But that's where I think that people coming from the SDI world, who are used to just grabbing a monitor and plugging the SDI cable in and seeing what they want to see, they're going to have a learning curve there. And while they're getting over that curve, it's going to seem more frustrating and maybe a little bit like they're going backwards. But like any new technology, like any new world that you go into, there's always going to be that curve. And SMPTE 2110 is no different in that regard.
Yeah, indeed, there are challenges to, sorry. There are challenges indeed for the 2110, but if you have, you know, good planning, if you think about what you need to do, if you have a good IT engineer, it's nothing that is really complex to overcome. It's really planning ahead, thinking about what you will need, you know, about your PTP stability and the multicast configuration and the bandwidth, you know, to plan about that, what you'll need. But as Andrew said, as soon as it's set up, it's working really great, and it really brings a lot of different ways to use, you know, your workflow. And I'm thinking, for example, of remote production. We didn't mention that, but we've had some customers who are doing remote production. So they have the cameras and at one place, and then they have a ST2110 signals going to a switch, and then one fiber going from that place to their location where they have the production switcher. So it's just with, you know, that's what's bring it possible to have ST2110. With SDI, you cannot do that because the location where they do the production is, I think, 5 kilometers away or something like that. So it really opens up different ways of thinking and of producing and so on. So yeah.
I mean, yes, ST2110, it offers the promise of scalability and flexibility, right? And it's all about while lowering total cost of ownership. And at the risk of repeating what my two colleagues have said, all of those are true once you achieve a true 2110 workflow deployment. The Nirvana state is all about that full high infra hardware layer, borrowing from the IT tooling and a platform that is interoperable. So at that point, you can change your workflow, you can expand it, extend it across your entire network. All that is great. The But the question is, how do you get there? So most of the challenges, to your question of where they come in, is in the transition phase. And there, again, from our vantage point, what we see is things like, okay, this is the flow, but what do you accelerate here? And what do you not accelerate? Which one is real-time critical? Which one is not? If you do accelerate something, which one do you put in fixed function? Which one do you put in software? Or which one is in leave-in software? Or which one is programmable acceleration? Where should you put your debug capability? We spoke enough about that, right? There's nothing wrong. It's not easy to debug this thing if something goes wrong. And they require different tools and engineering skill sets. I mean, IP is not a magic wand either. I mean, it's nice to say IP, right? But you get what you put in. And again, that goes back to the planning comments that I made. Spine and leaf router architecture was only designed for so many IOs and of so many rates and so many flows and so many megabits per second of uncompressed video. And getting the most out of that requires that you first do proper planning, either in pen and paper or with these tools that were referred to earlier. Vendors offering digital twins, that's like the high-end exotic view, or at least some basic modeling tools before you invest your money and build out your network, right? Careful planning and configuration. That was relatively easy in the olden days, not so anymore. So system design, again, topologically, architecturally, configurationally, like real-time management-wise, that design is what is the biggest challenge. If you get that right, I think you'll reach that nirvana state and life is joyous.
Sure, I think you really hit an important point in that the big challenge is when you have one foot in one world and one foot in the other world, trying to operate like that. That's always been the challenge. Even when we were doing the HD conversion, and you had people trying to operate islands of HD and SD plants, and you kind of went, okay, you really need to commit to doing this. I have one last question, then we'll get to the Q&A. And Andy, I'll address this to you. It's because we've talked about the complexity of these systems. So how does a platform like Mactica's MEP 100 help teams scale 2110 workshops while still staying flexible and able to meet the needs of the present needs and the future needs of their systems?
Well, I mean, so I think the one thing that just pops to mind is that is the word simplicity. Sometimes, I think of simplicity as being easy, and actually it's kind of almost the obverse of easy. In fact, one of the challenging parts of really communicating the advantage of that MEP 100 is that it does a single thing very, very well. It's taking, all of the complexity of SMPTE 2110 and really just boiling it down to a frame buffer API, right? Which, to people that are more, using 2110 to do production, that might seem kind of abstract to them, but what the MEP 100, bottom line is really doing is enabling engineers and software developers to build the modern tools that scale, and in the way that modern tools are built today. So that to me is really exciting. I love, Softron's on the call here, so I'll send praise your direction. I love companies like Softron and other companies like that are taking a very software-centric approach, a very modular approach, one that recognizes that really there is no, one size does not fit all at all, and so, you taking advantage of the flexibility that the PC platform brings us, and also bringing SMPTE 2110 and live production workflows into a space where you can script it, you can describe it, you put it in a GitHub repository, revise it, and really kind of treat your video system as you would if you were really doing any other kind of IT task, which is just going to make it much easier to find tooling for it, much easier to scale it and manage it as it grows and matures with your organization. So yeah, I think the MEP 100 and also I'll just wrap up by saying the M2S SDK generally. And the reason I mentioned that is that's really the front end of the MEP 100, and having that M2S SDK means that now your team can develop on any of the three platforms, Windows, Mac, or Linux, using a common SDK, and that just gives them the flexibility to solve the problem in front of them in a much easier way. Depending on what their challenge is. So.
Yeah.
Oh.
Yeah, totally agree. I mean, a platform like NEP 100, I mean, that's ideal for a software-defined broadcasting flow, right? Because it enables.
Hello, gentlemen. I apologize for interrupting, but we've got about 8 minutes left in the webinar. So I just want to make sure that we get to some of the audience questions that we've received.
Yes.
Okay, fine.
Apologize, folks. This has been a very fascinating discussion, and I'm enjoying it. But we do have a couple of questions that have come in. First one's a pretty basic one, and it's targeted for Shreya and Pierre. And it's, will the Softron Macnica, I guess Andy as well, will the Softron Macnica record it, play out, solution support ST211040 ANC flows?
Yes.
Yeah, okay.
Yes.
Yeah, I figured it was a simple yes/no question. So
can I throw in -40 and -41? I'll say that as well. We now have support for both of those. So yeah.
Okay. So pretty much you've nailed down all of ST2110.
Yeah, well, and I'll just say, it includes that, and it also includes NMOS as part of the application. So it's really a full stack SMPTE 2110 API, and yeah.
Okay. So I think everyone's sort of touched on this a little bit, but I think it's important for the audience to hear this. Is so once you move to a 2110 or an IP-based architecture, how does troubleshooting change?
Well, it changed from taking an oscilloscope and checking your SDI signal, and now, well, instead of doing that, you start Wireshark.
Yeah, I was going to say Wireshark. Yeah.
Or there are other tools, where you need, but there are different tools, of course, that you need to use depending on what you want to analyze and monitor. If you want to monitor the PTP alignments, if you want to check your bandwidth, it will depend. Depending on what you're looking at, you will have to use different tools. But I'm sure Shrey knows more than I do on that.
Packet sniffers, timing also, you'd spend more time trying to chase down. I mean, at some level, the user doesn't really chase down these things. I mean, they fall back on the vendor. This is why participants like us have to show up with more than just an FPGA and a piece of silicon. There is all those tools that I outlined earlier have to be brought in. And those tools now have to understand SMPTE 2110 at that level, where it understands the distribution between the different audio, video, and ink streams, and is able to debug which one is blocked where. So yeah, but you will definitely have to get your mental fingers dirty, and maybe your real fingers too, with packet sniffers and timing generators and that kind of stuff, which frankly you do in SDI world also, but they're largely resolved. But now it's a network analyzer kind of tools are probably the ones that you'll spend majority of your time trying to chase down problems, I guess.
Yeah, I'd say, yeah, I think those are great points. I think, a couple of things we mentioned. Wireshark is a popular one. Also, Briggs Technologies and Packet Storm, and there's others out there that make dedicated equipment to spot issues. One thing I will say that is, a point of emphasis for people is PTP. Really understanding PTP, setting it up. There's PTP analyzers out there that can catch issues that are common, but that's an area where sometime designing the system and also figuring out what tools you need there are. There's PTP TrackCom, but there's other ones too, and Wireshark again is another thing that's important there. So.
I will say, before I move on to the next question, I will say, and I do appreciate the idea of using Wireshark, but I will tell people, if you happen to be in a system where your administration is handled by a larger organization. I work for state agencies, and so you have a big boss. you start running things like Wireshark, you start setting off alarms, and so you want to make sure that you're communicating with the people who administer the system what you're doing before you do it.
Yeah, that gets back to, again, it's like the political side of things, and realizing that we like to talk about SMPTE 2110 as being on a network and we can put other traffic on there. But the truth is, for most people, your 2110 network and traffic is going to be in its own space. And making sure that your IT department knows that Wireshark is going to be part of the picture is probably a good thing to do up front.
So I got another interesting question. I think folks could answer this, and I'm kind of curious about this one. How is a smart NIC different from BMD 2110, DECLink, or Mellanox?
Well, I would say that they're kind of aimed at different targets. The MEP 100 is, it's a dedicated smart NIC. It's also one that has really been tuned and kind of set up for broadcast grade production. So that means that our, the amount of time that we promised to have the card around and replacements for it is very long. It's, it's designed and tested to be environments that are a little more extreme. So there's that end of it. The other side of it is that the MEP 100 is a dedicated, real-time FPGA card that is offloading the entire SMPTE 2110 processing stack. So, we're not writing packet headers in CPU. We're not relying on a general purpose NIC that has acceleration to do the job. It really is purpose-built for this task. And as a result, you'll find that the tuning for it, the amount of latency that there is in the system is very low. And it's just, it's much faster and easier to get to really that maximum performance. The other thing I'll mention too is that, we also have a little bit more flexibility because we are built on an FPGA. We're able to offer different versions of the card that can accelerate JPEG XS right on board, or we provide, we're not doing it on board, but we provide the ability to bring through ProRes content, as Pierre was mentioning earlier. That kind of flexibility and that ability to accelerate, for example, JPEG XS right on the card, which gives you a lot more resources to, for your GPU, is an advantage that you get when you work with real-time hardware like the MEP 100. So those would be the main differences, I think.
I guess the other way to ask that question is, what would it take to buy a Mellanox card and replicate the same experience as the MEP 100 does? And I think that kind of question speaks for itself. A, because it doesn't have an FPGA on board. B, it is not tuned for these particular use cases. It doesn't meet any of the SWaP-C. So it's not so much the underlying the PCIe card that matters. It's the solution that it brings, the value proposition it brings in the context of SMPTE 2110. Prepackaged, validated, the right things accelerated, which is why you needed an FPGA in the first place, and the other things left, the software layers, all wrapped with that buffer API. That's where the value comes in, not in any one particular element like the PCB. Right? That's how I would say it.
Well, gentlemen, it looks like we've reached the end of our time. I want to thank you all for it just flew by. I want to thank you all. It's been a fascinating. It's been a fascinating discussion. It's and something I've really enjoyed. I've enjoyed moderating. I thank you for your time and for all your expertise in helping our audience better understand how to deploy 2110 at scale. And with that, I think I'll hand it back to the home office.
Thank you, Bill.
Well, thank you, Bill, and thank you to the panelists and our audience for attending today's webinar. Please note that you'll receive 2 follow-ups after the event, a brief survey about today's presentation. We'd greatly appreciate it if you could take a few minutes to share your feedback, and an email within 24 to 48 hours that will include a link to the webinar recording so you can revisit or share it with colleagues. On behalf of Macnica Americas, Altera, Softron, and SMPTE, thank you for joining us today and have a great rest of your day.